Hello everyone, welcome to the next session of AWS Certified Cloud Practitioner. My name is Anant Tirmanor and I have over 16 years of experience mainly in data management, data analytics. I am a Google Certified Professional Cloud Architect. Um, I have over 3 years of AWS experience. I've recently completed my AWS Cloud Practitioner Certification. I wanted to share with you guys how to get this cleared in 2 weeks. And I also have a good comparison of AWS versus GCP because I have 3 plus years of Google Cloud experience as well. Last week, we covered a few chapters in this cloud concepts and security compliance. Today, we'll continue with the rest. So we'll start with technology. Security and compliance, we covered a lot of theory and a lot of questions. Today, we'll go with technology and we'll do a lot more theory. And from tomorrow, technology is going to be longer than 2 sessions. It's going to be 4 sessions. So we'll cover a lot of theory today. Tomorrow we'll go with most of it theory and a little bit of questions. And the last 2 sessions will be more theory and a little bit of sample questions as well. As always, don't forget to hit the like button, subscribe to us. You'll get a lot more AWS related materials. Thank you. So to get into the technology that AWS provides, we have to understand how do we provision and operate in the cloud. So there are a lot of ways of provisioning and operating in the cloud. Typically, this comes up in different forms of questions, but we can actually do it in these ways. Like typically, you must have seen that during the AWS Management Console, which is the website, you log in and then you are able to like click, choose, type in a few things, and then do it. So that's the most easiest way to get into AWS, but that's not what we always use in real life. So there are other ways. So we'll start from the top there. Programmatic access. You can use APIs. AWS provides APIs for all the services. You can invoke those APIs from your program, from your like command line. You can do it either any of those ways. You can use SDKs. AWS also provides software development kits. So if you're using Python, Java J2EE, C Sharp, you have specific SDKs for whatever kind of environment you have or whatever tools you're using. Use those. AWS Management Console we covered. That's just the website where you put in all the information. CLI is the command line tool. So AWS provides a Linux-like command line tool. You can go in and run the AWS commands. Say you could start the EC2 instance. You can stop the EC2 instance. You can provision new resources. So you can invoke that to like start or stop services, or to even provision services. Provision services is to create a new service, like set up a new EC2 instance. That's a provisioning. That's something like a provisioning. At last, you can use infrastructure as code, like if you've heard of Terraform or anything like that. So instead of typing in your code every time, you can type in your commands every time to do it. Say you might have a typo or something like that. You can have infrastructure as a code where it all these commands are like encoded, and then you can actually like set up the same infrastructure. Say for example, you set up a dev environment using like two EC2 instances, and then you connect them using you create a subnet for them, and then you create a virtual private cloud for them. So you create a few AWS resources, and then you set up a few things. You can do the whole thing as one set of command line command like one set of commands together, and then use that to provision another dev like environment. Say you're provisioning QA, which has to be similar to dev, but it has a slightly different like CPU level, RAM level. You can use all those things from dev, but just change those few things and then re-implement it as infrastructure as code. So infrastructure as code is more like doing things using a command, but you can do a lot more at a time. So how do you actually provision your resources? So if you're coming to cloud, from the first, we'll start from the rightmost here. So the on-premises deployment model. So if you're completely having a solution that is on-premises, all your servers are run by your company or by an outsourcing partner who takes care of all your uh, like servers and storing them, temperature controlling them. So all those are taken care on premises. So you can deploy all your software, all your applications on these servers that are on premises. When you come to AWS helps you still have certain code on premises, but they suggest that um, using application management and virtualization technologies so that you can increase the resource utilization, and eventually that may be cloud ready one day, or if that application is never suitable for cloud, at least you're using your resources much better. The middle one here is the cloud deployment model. So this is what um, like if you're deploying a new application on AWS, you can build everything on cloud. So all your application, all your databases, all your data, everything lives in the cloud. You don't build anything with your company's infrastructure. To do this, first we have to build something called a VPC, which is a virtual private cloud. This is impenetrable wall that we build, but it's virtual within AWS. So within AWS, you can provision say one server and a database, but you can put those into a virtual private cloud. That way, there is the entry and exit from to the virtual private cloud is like completely blocked, and then you can decide that there is you people can reach through this gateway, and the virtual private cloud keeps like anything within that secure, like limited for any other application cannot really get into this virtual private cloud to get the data, like search up anything or like hack anything inside it. So the cloud-based application is completely in cloud, and typically it's done for applications that are built uh, from the scratch. So, like if you have a current application, you're replacing it with a different application. If you start building it completely in cloud, then this approach is taken. Or if a company is building a new application and they want to like build everything in cloud, then they can take the approach of cloud deployment model. Um, Obviously, you can you with cloud deployment model, there's no infrastructure to take care of. All scaling, all those things will be taken care of by the cloud. The third one, which is the leftmost here, is the hybrid deployment model. Hybrid deployment model is suitable for certain applications when we have certain applications that are already on premises on the cloud, but we're building either new applications, or we are moving one part or one of the applications or a few of the applications over to the cloud, and then we want them to be able to talk to each other, or they're not completely independent applications. There may be some interfaces between them. So in that case, we build a hybrid deployment model. So some of our applications are in the cloud, some of our applications are on premises. And the reason for staying on premises may be either it's a legacy application, you don't want to really migrate it, or you might have other security considerations, other considerations such as like sunk cost. You've already bought the servers and you want to run the life of the servers out. So there will be multiple reasons why you want to still have on-premises applications. And in this scenario where you do hybrid deployment, note that we still build a virtual private cloud, and within the virtual private cloud we put in all our compute. The computes are all servers that do all the computing work for us. Um, so essentially, instead of having a server on premises, you create a virtual private cloud on AWS and provision like servers, or in our instance, it could be a EC2 instance, or it could be a Fargate, or it could be a Lambda function, or any kind of compute that AWS provides. You build that within the virtual private cloud, and then um, that has a connectivity with our on-premises data center. So those are defined based on the rules that we have for entry and exit into the VPC. So this way, our on-premises servers can talk to the virtual private cloud on AWS through the internet, but like they have secure TLS, SSL TLS connections through which they speak. So those are encrypted. So the communication between the on-premises data center and the AWS is encrypted, and we have specific entry points where only our on-premises data center IP address can inquire or hit the AWS cloud. So we can set up things like that. Or if you want AWS cloud applications to be reached out from anywhere on the internet, not only from your corporate network, then you can set that up on your VPC to say that if somebody hits this IP address, then they are able to get through from anywhere on the internet to this particular like compute server or something like that, and then from there it does a lot of bunch of stuff and then gets the data back. So all that can be set up using the hybrid deployment model. So this is something they ask a lot about. I've typically seen at least one question comes from the deployment model per se. Either they could ask about which deployment model is the right for this scenario, or they could provide a scenario and ask why one is preferred over the other. So if you can reason that out, those might be one of the options, and you have to choose the best reason. Now that we are into technology, we're going to look at these services that AWS provides. Storage services. These are where uh, like we store our data and then we retrieve it. Compute services. These are like servers that are on the internet on AWS, and those can be provisioned. Sometimes we use serverless compute services. That means you don't really have to provision a server. You just use the server that's available at that time, and AWS kind of manages the underlying server for you. Database services, anything with respect to RDBMSs or NoSQL databases, those come under database services. Networking services, this is where we have our Route 53, we have our anything to do with networking. Analytics and machine learning services. Migration services, how you migrate data from and to the corporate center or internet into AWS and outside. How do you have like application services, media and mobile services, management services, and developer tools. So we'll concentrate a lot on the previous slide. So not many questions come in from these slides, but they may come up then and now. So we'll go through them quickly and address all the important parts where you might get questions from. We'll start with the storage services, obviously. Storage services, as we said, we could store data on the Amazon AWS environment. The major things we need to be aware of are Elastic Block Store, Elastic File System, AWS Backup, AWS Storage Gateway, AWS FSx for Lustre, Windows File Server, and AWS FSx for two other systems as well. Cloud Endure for disaster recovery. So let's get into each of them. The file system is the first one. So AWS Elastic File System is where, if you look at to the right, like whenever we want to set up a file system, so we want to set up a place where you can actually browse files through folders and get through information. Those are stored in folders. Those typically are stored in Elastic File System or EBS. So one of that option is Elastic File System. Let's look at that. Elastic File System is something we use along with a server, or in Amazon's instance, it's called the Amazon EC2 instance. So we can't use an Elastic File System without a server. So the Elastic File System is only a place where you have folders and files stored, and you can retrieve them using a server that is an Amazon EC2 instance. So in this example, in the right, we have created one VPC, which is a private cloud for us, within which we have three subnets. The dotted blue lines are three subnets, and the three subnets are in three different availability zones. So within each subnet, within the first and the third subnet, we have an Amazon EC2 instance, and that those are able to those have for the in the leftmost one, Amazon EC2 instance, we have two servers inside them. Those have two different IP addresses, and the last one and the third one on the right has another EC2 instance with another IP address. To read any file, we set up a mount target for those Elastic File Systems. So all these three EC2 servers can write or read data into the Elastic File System based on the settings. I'm just assuming they can write and read, but after they set up a mount target, we can set up the permissions as well. So the Elastic File System can be updated using the EC2 instance. So Elastic File System in itself is a simple serverless setup. So you can just you don't really have to say, I need this server, and then you install this file system on it. So to set up a file system, you on your on-prem, you will have to first set up a server, and on that server you'll have to provision resources for a file system software, and then that file system software will have to be installed on it, and then though that will have to be managed. If it gets less memory, then you'll have to reduce it. If it's using too much of the memory, then you have to increase the memory. If it needs more hard drives, you'll need to like either add more hard drives or find another solution for your like storage space. But Amazon EFS, this file system is completely serverless. You could set it up and then forget it. like more data is needed, Amazon EFS will scale it up, and if it's not being used, it will scale down. So you don't have to worry about any of the settings within the Amazon Elastic File System. Um, Other than provisioning it with the most minimal settings, you don't have to like worry about the RAM of the server, or like what kind of software the server has to actually have host the file system. EFS is a NAS service, so it can scale across thousands of instances and scales at petabyte scale. Another thing you understand is, even though EC2 instances are built on each availability zone, Elastic File System is available across the zones. So you don't have to within a region, if there are different zones, you want to still like mount the same Elastic File System, you could still mount them. The next one we look at is Elastic Block Storage. So this is another instance where you need a EC2 instance to actually read the Elastic Block Storage. Here we provide low latency block storage, not a file storage, but here we store them in blocks. So it can be a bit complicated to set up. So you'll have to choose the volume type, what type of volume you want. Is it a like a hard drive, or is it going to be a solid state drive? So those are things you'll have to choose. You might have to choose performance requirements. If you want it to be read optimized or write optimized. So those are kind of things you'll have to choose in the options. Again, here this is serverless too. You don't have to actually choose like a server to run this. This is more of choosing what kind of volume you want. Like, is it going to be 10 GB or 100 GB? So those are type of the options you'll have. So you'll have to choose all that. This doesn't automatically scale up or scale down. So if you chose 10 GB, it's 10 GB whether you use it up or not. You're still going to have 10 GB provision there. And if you need more, you'll have to provision more. EBS is typically designed for hosting applications and storage. And if you have high volume databases, those can be stored like with easy reach to the EC2 instance. So those again have to be linked to a EC2 instance to be able to be used. So EFS and EBS have to be linked to a EC2 instance. The next one we're going to look at is the FXX system. So this is a file server or a file system. So Amazon provides like 4 different file systems. So like Windows file server, the Lustre, the NetApp ONTAP, and OpenZFS. So those are 4 different file systems that are widely used. And like what we essentially need to know is, this is a like easy to launch, easy to run, easy to scale. It's a high performance file system on the cloud, and if you want to, it's a fully managed service, so you don't have to really provision a hardware, patching up any of the hardwares or anything like that. So all you have to do is choose the options based on like what type of Amazon FSX do you need. Do you need it to be a Lustre, Windows Server, ONTAP, or OpenZFS, and also how much, what kind of levels you want to use it with. So those are very simple options you'll choose and then you use. From the exam perspective, what you need to know is, if somebody talks about, they might confuse you between different storage types. They could ask you something about an S3 or a EFS or EBS. and a FSX. And they might ask, when is this? They might give you a situation and ask which one is the most appropriate one. So whenever we need a file system, and that needs to run on its own, it does not need to be connected to a EC2 instance. We choose the FSX one. And within FSX, typically they ask the question about machine learning workloads. So if you have a lot of compute workloads, you would choose the Amazon FSX for Lustre. And if you have a .NET based application, you have Windows based application, and you want to run something on a Windows file server, then you would choose the Windows Amazon FSX for Windows file server. If you want to use anything with your EC2 instance, then it has to be either EBS or EFS. And within EBS and EFS, if you want it to be completely scalable and able to be attached to any number of EC2 instances, then you use a EFS. If you want it to be like an SSD or a HDD, and you want to be able to provision it to a EC2 instance, then you use the EBS. So that's typically how they ask the questions. You don't have to go too much into detail. The detail that I've provided here, especially we understand the highlighted parts, that's enough. For the AWS Certified Cloud Practitioner exam, obviously for any other exam, you'll have to go a little bit more in depth. The most important, typically you will get at least 3 questions about this topic: AWS Simple Storage Service, Amazon S3. You might have heard about S3 buckets. This is an object storage service. So this is a keyword that if you remember, you can answer at least a few things. An object storage service is different from a file storage service because it doesn't store them in a folder structure. It doesn't store them in a file structure. Rather, these either text files or images or whatever we store in go into different objects, get stored as different objects, and these are retrievable uniquely from the internet. So there's one unique bucket name that you choose that cannot be within the region. It's not region specific. It's not availability zone specific, unlike the EBS or EFS or FSX. This is available. You do store what region you want to store it in, based on which users use it most, but it's unique across the world. So there's one unique IP address with which you can actually go and retrieve it. So say you build an app such as Instagram where you're able to share photos. All those photos can be uploaded into multiple S3 buckets, and then those are stored as objects, and then those can be retrieved much easily from the internet, and you can set it up such that we don't have to go navigate through a file system to get the data. It's available on the internet in a unique IP address that you have, and then you could retrieve that and show it up on your app. Okay, so let's see what are the types of things that we store in the S3 buckets. So we typically store anything related to like images, videos. So if you're a Netflix like application, you want to store videos that other people access from different places, then you load that into a S3 bucket. These don't really go into a database. Those don't fit into like a server. You don't build an EC2 instance and store them because those are specifically for compute workloads. So you rather use this simple storage service S3 bucket, and then you store those videos, and those get retrieved by your users whenever they watch that video. Okay, so S3 bucket is a is an object storage service. It provides highly scalable. This means if a lot of people use your downloads, like look at your image, or like very few people use it, you can scale it up and down accordingly. It it's not going to be the data availability is is very high. So it's rare that the server goes down and you're not able to access the data. The data availability is pretty reliable. The security of the system is 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 very high. So they have obviously, because it's on the internet, you should be able to access it only if you have the permissions to do that. So there are different IAM rules you can specify for the buckets, and you can ensure that nobody else other than the people who are intended to look at it can look at it. And performance. The last thing is durability. So S3 is designed for 11 nines of durability. That is, like when you try to access it, and say the file goes bad or file goes missing, you have 99.9999 11 nines of like probability that it would still be available, it's still retrievable. It's not, the file's not broken. So S3 is designed such that there's 11 nines of durability in that. So a few things to understand: you can store unlimited amount of objects, so you can just store a lot. You just have to pay more for it. That's one thing you need to understand. Next thing is, you can store anything from a like 1 byte of information, small text file, to a large 5 terabytes of files. So you can just, you have a huge range of information that you can store. And you also have something called multi-part upload. So multi-part upload is where you can use it using a command line tool or using the web interface, but you can upload it part by part. So here you can see a lot of buckets there. These are different storage classes. We look at that pretty quickly. S3 Glacier is a specific service that that is separate from S3, but it's very much related because it has the same functionality. But if you want to, and S3 Glacier is also a storage class, so sometimes people might get confused. I haven't seen questions on this on this exam, but if you note that there's also another service called S3 Glacier, and you could get confused by S3 versus S3 Glacier. But they don't typically confuse you between the S3 Glacier, which is a separate service, versus S3 Glacier, which is a storage class within S3. So S3 Glacier in itself, like you has a management console. You can create and delete walls, and then you can use the CLI to actually like upload data or retrieve data. And S3 Glacier is meant for any data that is stored but very rarely retrieved. Okay. Now we look at the storage classes. So these are the storage classes. The Amazon S3 standard is what you would typically use when you don't really have an idea of how long this file is going to be used, how many people are going to download it, how often is it going to be retrieved. Then you put this in a S3 standard bucket. If you want Amazon to be intelligently thinking about which tier to put it in, then you use the S3 intelligent tiering. Okay, so let me step back. So these are storage classes. That is, these are things that you choose as options when you set up a Amazon S3 bucket. So when you create a S3 bucket, you choose what storage class you want that to be in. And based on what you choose, you will have to either pay higher or pay lower. And typically, the lower paying option would be for files that you rarely retrieve. So you upload to Amazon S3, but you rarely use. You use it once a year or once in like 10 times a year. So those you typically pay less. So you would rather put that in a storage class which actually corresponds to that, so that you can actually Amazon can keep it in a different bucket, in a storage class such that they also have to charge less for it. So from here, from the if you look at the rightmost one, S3 Glacier Deep Archive. So this is where storage is where you if you want to retrieve a file, you may not immediately get it. You might have to wait for a few hours to a day to actually get that information. You're not going to lose that information, but it might just be on a tape which is not immediately connected. And if you want to retrieve it, you go request for it, and then it like get the URL, and you might if it's available on the immediately, it will probably you will get it immediately. You just look at it. Otherwise, it will run a request. It'll there'll be a robot which goes in and pulls the actual tape that has this information, gets it back, loads it back on the server such that it can be read on the internet. That is Glacier Deep Archive. So those are used for really rarely used files. And S3 Glacier is for slightly infrequent used files. And let's start from the top again. So S3 standard is when you don't know where like whether how frequently it will be accessed. You put that in a S3 standard bucket, or you don't want to think about how frequently the file will be used. You can put it there. Or S3 intelligent tiering is where you don't want to really think about it, but Amazon could move it into different tiers based on how frequently that file is being accessed. If files are being accessed frequently, then it'll keep it in the standard bucket. If if it's rarely used, it will move it from there to the to other buckets. So those that is done by AWS itself. So you don't have to worry about like how much where you need to put those each different file in. And then because Amazon is moving the infrequently accessed files out, you'll have to pay less than what you pay in S3 standard. S3 standard infrequent access is in between S3 Glacier and S3 standard. So those are like long-lived files. So files that you have for a long time, but you frequently don't use it. So people don't retrieve it on a daily basis. So those you move into a one zone infrequently accessed. And here one zone means that it is stored only in one zone. It does not have a copy across availability zones. So it because it's not, if one of the availability zones go down because of network issue or a calamity or something, so only that information that is stored in that one zone will not be available to you on the internet. So it's not built for fault tolerance or for disaster recovery. The next one is Amazon S3 Glacier and Deep Archive Glacier. So those are meant for long time archive. Typically, like I was working in a bank, they had legal requirements to store checking account information of all the account transactions of all the customers for 7 years, and mortgage account transactions for 7 years. So those the information that is stored there would be rarely used, but it can be requested by the law enforcement or by for some regulatory reason. So it has to be stored by the bank. So for that reason, it was stored in an infrequent access, uh, like in like for the mortgage application, we uh, accounts we stored in a S3 glacier. Once like this is a you can also have a life cycle policy. So you can say that any file that gets uploaded for the first 3 months, it's in S3 intelligent tiering, and after 3 months, the lifecycle policy will automatically transfer it to a one zone infrequently accessed. That's a lifecycle policy. When you set up the S3 bucket, you can also set up a life cycle policy, so that will transfer between different storage classes. So here, a lot of questions come between, like, um, this is the scenario: will you store it in S3 glacier, or will you store it in S3 intelligent tiering, right? So that can be one of the questions they ask. So which is the suitable one? They would give you a scenario and ask you which one is the best suitable storage class. So now that we looked at Amazon S3, EBS, and EFS, definitely we'll have some questions around what is the difference? Why are there three different things, right? So like if you look at the right, um, so EFS, it's a comparison between S3, EBS, and EFS. If you have like unstructured data, like just files which are like images people share, photos, videos, text files, your logs from your servers, or like you have equipment, and the equipment throws in a lot of a bunch of logs or output um, from your medical equipment. So those things can get pulled out and stored into a Amazon S3 bucket. Those are not something that go into a database or into a file system. So those get thrown into a S3 bucket. And this is completely self-managed. So you don't really need a EC2 instance to feed this data. Anybody on the internet can access it. Any API can access it. Um, like any programmatic like if you have an API, if you have a like program that you run from an application, you can use the S3 bucket information. You don't need an EC2 instance to actually query the data which is on a S3 bucket. But that's not the case with EBS and EFS. Those two need a EC2 instance to actually mount the data or use the data that is stored there. The biggest advantage of S3 bucket is that it has multiple availability zones. So each, unless you have one zone infrequent access, the data is automatically stored in multiple availability zones. So the data is pretty durable. That's the huge advantage of S3. EFS versus EBS. EFS is the more expensive option, um, in the sense that you pay more for number of GB, but EBS is kind of a local storage. So EBS is is like a hard drive that you can connect to one of your servers. So it cannot be shared across by multiple servers. So you pay for each EBS instance. So if you want to store some information in 3 EC2 instances that you have, you will have to pay for it 3 times. While in EFS, it can be mounted. One EFS can be mounted to 3 different EC2 instances, which are across availability zones. So you can have the same EFS instance like mounted to 3 different EC2 instances, and you just pay for that one Amazon file system, EFS, Elastic File System storage. So how many of a GB you pay for that. So if you want to run an application with a lot of memory that you need to use, and because of that you add a EBS to a EC2 instance, not memory, I mean you need a lot of storage, and that application needs to run for that server. Then you attach a EBS instance to the EC2 instance, and that attached storage EBS instance, like even if the EC2 instance fails, the data in the EBS is persistent, so you can have that data. You just have to set up a new EC2 instance or recreate that EC2 instance and then attach it to the EBS volume, and then you can use it again. So again, if you go back to that right most EBS versus EFS, if you want any system storage for that particular EC2 VM, virtual machine or server, then that is done by EBS. If you want data storage that's scalable and it has to be shared by multiple EC2 instances, that is done by EFS. So there are a lot of questions that come up, like asking which one is the right service for this. I think these pointers will give you all the information you need to answer those kind of questions. The next set of like services we're going to look at, storage services, are like Snowball and Snowmobile services. Essentially, a Snowball edge, if you can look at the picture there, and the person holding the small computer there, the gray box next to the big computer is the Snowball edge, and the big computer there is the snow cone, is the Snowball. So the Snowball and the Snowball edge are meant for like computing workloads plus storage workloads, storage services that are provided like on premises. So but those get like you can use that in your environment, in your local system. Say for example, this was used in a lab, so we were working with a like a a cancer research facility lab. They were analyzing a lot of data, and they wanted that data to be sent over to AWS. So instead of connecting over the internet and sending it, like Amazon sends you this box, which is a Snowball, and then all the information that the lab generates gets stored into this Snowball machine, and then that gets shipped over. You put it in a FedEx or UPS and send it over to Amazon, and Amazon pulls all the data into the cloud, and then now they are available in the cloud and you can use it. So typically they move into S3 bucket. So this was one example where I've used. I've not seen any customer yet use the Snowball edge, but I heard about a shipping container vessel where like a vessel has a lot of like refrigeration information, information about its temperature, information about its humidity. All those are measured by shipping containers that go from ships from say China to US, and within the containers they have these edge computing boxes, which is the small box to the left of the person is holding. It's called a Snowball edge. So those collect all that information, and then when the shipping container comes back on shore, they pull the shipping the edge out of it, and then they ship it over to Amazon, and then Amazon uploads all that information into the cloud, and that information is usable whenever they want. So that is the use of Snowball and Snowball edge. So that's where you have storage on premises, but then to transfer it over to AWS, you just physically store it in that device, and then ship it over to Amazon using a FedEx or UPS, and then Amazon uh, puts the data online, gets the data online. The Snowmobile is used for huge data services. I've never seen a company use this, but I assume people um, who want to transfer like exabyte level of data, um, then you use your Snowmobile. So in this instance, you like put it in a hard disk or hard drives in lot of hard drives, and then an actual truck comes in, and you can send in that the data that you have, and then it physically moves the hard drives to Amazon's like data centers, and then the data gets transferred there. So this is used like typically internet today is really fast, and if you're not using um, like if you're using terabytes of data, even say 1,000 terabytes, like it can be done using internet. But when you're having like exabyte or petabyte level of data, uh, like moving through the internet might take you months or like years. So in that instance, it's better to call in the Snowmobile and then get the actual data transferred. How cool will it be to actually like have so much data that you can't even transfer it over the internet, and then a truck has to pull in, and then you move it physically, and then that gets in there. The snow cone, we look at that the next slide. The snow cone is part of the Snow family. It's another edge computing device. So here there's an example where in healthcare you use it as an IoT hub. So you process and transfer data. Like any kind of like if you look at that image there, I think it's an example AWS has on its website. So they use it in a healthcare system to process those images. So the snow cone has not only storage capacity, but it also has computing capacity. Um, so they are able to process those images, and then that whole image, the whole system can be like whatever it stores, it can be shipped, and then that can either come to AWS and then we can do it. Or if the customer wants to keep it, this is typically used for short-term purposes where they don't have their own computing power. So they build this up, and then say it's a workshop they have for a few weeks, and then they want to do all this work, and then they want to send this up, so they don't have to get their own computers for doing that. So they can get the snow cone. This has both computing capacity and storage, so they can use all this, store it there. And if they want to use it for a longer term perspective, then they can just connect to the internet, and all the data that is being need to get stored in on AWS can get synced up there using AWS data sync. Or you can actually physically ship the device when you're done with it, uh, pack it up, ship it, and then it gets into AWS data warehouse, and they can actually upload it for you. So those are part of the Snow devices. The last part of storage is the storage gateway. Storage gateway is a set of like hybrid cloud devices. So whenever you need some information on premises and some information that you need on the cloud, it's suitable to use storage gateway. The storage gateway, it it is installed both on premises and on the AWS cloud. So what happens is it helps the data transfer between AWS and on premises. So whenever you want to move a daily backup from your on-premises into the cloud, or you want to have cloud stored, like whatever you have on the cloud, you want a local copy of it on your on-premises. So for these things, you use the storage gateway. So storage gateway manages all those data transfers and anything that, like say for example, any information that's related to a particular uh, set of profiles. You want those get backed up from the cloud back to the on-premises. So you can set it up. Say for example, if one of the states has a law stating that any information that they have on those states' customers need to be stored on premises within that state. So those kind of laws can be utilized using this. So whenever it gets stored on cloud and we find that that particular customer is from a particular state, then that information can get backed up onto the on-premises, and then we either delete the data, customer data from the cloud, or if the state's regulations allow, you have a copy of it on the cloud, and you also have it uh, within the state in a on-premises data center. That kind of gets us to the end of storage services. So the next session we look at compute services. So the compute services are essentially where you have a server on your internet, and we use that server's computing power to run our application or to run our API. And in the cloud, we don't use a whole physical server. What we use are like virtual machines which are on top of a physical server. Um, so a virtual machine is completely walled out, um, uh, like a piece of software that walls out from the server a portion of the RAM, a portion of the hard disk, a portion of the CPU, so that it builds its own virtual machine. So a server could have multiple virtual machines inside it, but that virtual machine is completely walled, and that virtual machine is used only by the person who has access to use it. So when Amazon gives you a computing power, so they like for example, EC2 instance is the most commonly used virtual machine. So that is a virtual machine. It's not a whole server that you have access to, but you have a virtual machine. You could still set up an OS on top of it. You could choose what OS you want to use, whether it's Windows or whether it's going to be RHEL, Red Hat Linux, or whether it's going to be Ubuntu Linux. So you can choose all that within your EC2 instance, but those are actually virtual machines. So within compute services, you want to look at the first four categories, which are most important, and the last few I'll cover them without giving them too much importance. Uh, so in the next session, we will focus a lot on the compute services. The first set is Amazon EC2 instances, which is um, provisioning your own computing servers. A Lightsail and Amazon Elastic Beanstalk, those are to make your life easier. When you set up a EC2 instance, then you'll have to build something called an autoscaler so that you can add more when there's more traffic, you have to add more EC2 instances. So those kind of things get done, and you need to build a network. So you need to do a lot of things when you set up a EC2 instance. It's just not setting up a EC2 instance. So to make that easy, Amazon has those Lightsail and Elastic Beanstalk services that kind of bundle all this work for you together. So not only setting up a EC2 instance, setting up the network, opening the network port for entry from outside. So all those things get bundled together, and those are easy to use services such as Lightsail and Beanstalk. We look at Lambda, which is serverless function. So serverless computing, where you just want to have an API exposed from outside. You don't want to really worry about what server, what kind of OS it has, and anything like that. You just want to write your code. Then you use AWS Lambda. Fargate and Appreneur are both Docker-based workstations, and so when you want to set up Dockers, you can set up EC2 instances and then set up a Docker on top of that, and then within your Dockerized images, you can set up multiple applications. Instead, you can use like Amazon's Fargate or Appreneur, which are suited only for running like Docker applications. And in this instance, we get a place where Amazon manages the EC2 instances, scaling them, and everything else underlying. Uh, we just worry about the Docker image itself and what image has to run for each Docker and how do you set up the Docker. So that is another set. And the last set where we talk about Amazon AWS Batch, serverless application repository, Outposts, Wavelength, and VMware Cloud on AWS. Those I'll cover a little quicker. So that is all for today. Thank you so much for watching. Talk to you tomorrow.